Hi, and welcome to the next video, which happens to be the third in this series of organic chemistry that I've been looking with thus far. In today's video, we're going to be talking about the homologous series. So let's move into what we have. When that word or that phrase is mentioned, don't get confused. We are simply talking about a family of organic compounds. Now, when we say family, just like you have a family you belong to, where there is a father, a mother, and then you have the kids. Now, among those kids, there is something that is shared in common among each of them, and it is called a similar DNA. They all share one DNA because they came from the same parents. In the same way, organic chemistry has that concept playing out, and it is called a homologous series. A homologous series is a family of organic compounds that possess the same functional group. We'll be seeing what this means as we proceed in this series. The same general formula, similar chemical properties, and a gradual change in physical properties. So let's talk about one example of the homologous series that we have. It is called the alkane family. The alkane family, which is a very good example of homologous series. When we say alkane, we're simply referring to a group of hydrocarbons that possesses a general formula CnH2n plus 2. What does this mean? It means that this N represents the number of carbon atoms that are present. The number of carbon atoms present in the molecule. The number of carbon atoms present in the molecule. That is what this formula stands for. And so, for instance, let's say we have an alkane that has two carbon atoms present. What this means is CnH2n plus 2 now becomes C. Anywhere we see N, we put the number 2 because we have two carbon atoms. So it becomes C2H2. Now instead of N, we put another 2, then plus 2. Altogether, this becomes C2H 2 times 2 over here gives us 4 plus 2 gives us 6. So we have C₂H₆. This will become the molecular formula for the alkane that we just solved for. So just by knowing the number of carbon atoms that are present in the molecule, we were able to arrive at the molecular formula. So here are some examples of members of the alkane family. We have methane. This is its molecular formula CH4. That is one carbon atom and four hydrogen atoms. One carbon atom and four hydrogen atoms. We have ethane, we have propane. Now, there's something about a homologous series or this alkane family that you need to know. Each member differs by CH2. What does this even mean? It means that consecutive members of the homologous series increase by one carbon atom and two hydrogen atoms as the chain gets longer. Let me explain. Look at the first compound, which is methane. We have one carbon atom and four hydrogen atoms. The next member that comes immediately after methane is ethane. How many carbon atoms do we have? We have two carbon atoms and six hydrogen atoms. Now, if I were to ask you what is the difference between these two, two carbon atoms over here minus one carbon atom over here, we have one carbon atom. And then six hydrogen atoms over here minus four hydrogen atoms over here, we have two hydrogen atoms. So the difference between the first and the person following it is simply CH2. That is what we have over here. And if you check, the difference between ethane over here and propane that is following it will also be CH2. So that's what we mean by each members differ by a CH2. The next person that is following the previous person has a difference of CH2, and that difference is called a homologous difference, and it is unique to the alkane family. Now, organic compounds generally have some physical properties. Let's look at them. First, they have low melting and boiling points. Low melting and low boiling points. The second is they are insoluble in water, generally most hydrocarbons. Now, there are some hydrocarbons that are very soluble in water. For example, alcohols. Alcohols are organic compounds and they are also hydrocarbons. But on a general note, most hydrocarbons are insoluble in water. In other words, they do not dissolve when they are placed inside of water. And then thirdly, most organic compounds are soluble in organic solvents. So when you place them in an organic fluid, they will dissolve. Then fourthly, they are less dense than water. They are less dense than water. What does this mean? It means when you try to mix them up with water, many of them will end up floating. For example, kerosene or petrol. You notice with me that when you try to pour some petrol or kerosene into water, the kerosene and the petrol ends up floating. Why? Because it is lighter than water, and that's because it's an organic compound. And then finally, they have poor electrical conductivity. They are poor conductors of electricity. So all these are because they have covalent bonds in between their structures and they have weak intermolecular forces. So because of this, they are less dense than water, they possess poor electrical conductivity, and the remaining characteristics that you can see on the screen right now. I hope this video has made a lot of sense for you thus far. Now, as the carbon length increases, we'll be seeing what that means, okay? As the carbon length increases, the boiling point also increases, because as we proceed, we'll be seeing scenarios where a carbon atom will be joined to another carbon atom, which will be joined to another one, and so on and so forth. So when this happens, the boiling point increases, viscosity also increases. And by the way, viscosity is simply a measure of a fluid's resistance to flow or deformation. What do I mean? If you have, for instance, a keg of palm oil, right, you would notice with me that in the Harmattan season, okay, now for those of you listening to this outside of Nigeria, the US, Canada, and all of those countries off the shores of Nigeria, Harmattan is simply what you may call winter when it's very cold. You would notice that that keg of palm oil becomes more like very solid, and when you turn the container upside down, it doesn't really flow. Now, that is called, or that means that the viscosity has increased. Why? It is now very, very resistant to flowing and deformation. But when you heat that keg of palm oil, it becomes less viscous. When you turn the container upside down, it flows more easily. So that is what viscosity means. And then finally, volatility decreases. Volatility is simply the ease with which a fluid changes from the liquid phase to the gas phase. For example, when you pour petrol on a surface, after a while you discover that all of the petrol has evaporated. Why? Because it is very, very volatile. So that's what happens when the carbon length increases. Up next, we're going to be looking at the interesting part that I believe you've been waiting for, naming organic compounds. I'm going to be taking this right from the basics, so it's something you absolutely do not want to miss. I look forward to seeing you in that video. Up until then, stay blessed.